Okay, so we're going to program this. First thing we're going to do, we're going to do a full chip arrays. First thing we're going to connect. And we're going to do full chip arrays. And we're programming an MP2DFN with a pill today. Because that's like what I happen to have on my desk right now. So we've got a fully erased chip with absolutely nothing on it. And then we need to go to this, and I've got a whole load of things already open. And the important thing is that in F405H we've got the MP2 v0.1 selected, and you can choose your board. And if we open this, then inside here we have all the settings where we can define our board and point it to the correct widgets and pin and so on. I'm leaving this unedited for today. So hit debug. We might have to go through this, but for now we can use the one I'm doing. And of course, we have to disconnect from that first, because you can't have two debugger sessions on the same debugger. You have to give it a little while to upload. And then we skip all the breakpoints, we hit play. So we can have a program machine and we had a ping because it's just popped up. Now we hit R on MobaXterm. You see arrived in the MESC console, type get all this, and these are the default values that things load up in. So the first thing we want to do is probably set things to the correct currents and so on. So set max, say 40 amps, set minus 40, and then we're going to want to change the measure current, measure voltage. Maybe you don't, but however. And then because we have a completely blank thing, we're going to say, see there it thinks it's saved it, and then we type measure, and we're going to say minus R, so we'll measure the resistance. In a few seconds, it comes back with 65 milliohm, and 69 microhenries, 160 microhenries, which are values that basically seem to work for this. Now, if we want to measure flux linkage, we type measure minus off, and that's one of the flux linkage detection measurements, which seems to work more reliably. It works by slowly ramping it up under open loop. And then once it's got a rough estimation of flux linkage, it sets it running and uses the flux linkage observer to find the true flux linkage. So now we type save, and that should now have the variables all saved. So now if I type set dot ref 3, there we've got, yeah, it's measuring blah blah so on. You can see the voltage, we see the bus current doesn't update when it's not running. The speed, you see, is basically a 0, and we've got the status. So if we want to set, for example, some field weakening, let's give it 10 amps of field weakening, and then we can get a small speed boost on that. Now, if we type get again, you can see we have various other settings, which we've got things like sensor. There's not actually any sensors plugged in at the moment, but we can do things like setting HFI type, and we can set the motor sensor to be HFI. So set HFI type 1. Is that correct? Yep, it says 45 degree. Set cell sensor 5. So now, says SL sensor 3 for HFI. So now we should have HFI for a startup. If we say set UART free. Maybe it's a bit less current so you can perhaps hear it. 0.5 amps. Accidentally set the SL sensor. Now you can hear the HFI running as it starts up. So we go with set HFI running there. And you can do similar for setting, for example, hall sensors or encoders. And that's kind of all there is to it, to be honest.